Time to talk about your parent functions. This parent is called the constant function. That's because y is going to be 3. We don't care if x is -5, +6, anything. Y will always be 3. Okay, let's talk about the properties. Notice that the domain is -infinity to infinity, that the range is simply 3. That's all. Notice that your y-intercept is at 0, 3. And as for the x-intercept, there is none. That graph does not ever touch the x-axis. Furthermore, the slope is 0. That's all I can say about that. Moving right along. About the linear function. If we take a look at this graph, well, x is going to be the same as y. Looks like my points are a little bit off. If x is 1, y is 1. If x is 0, y is 0. You get the idea. If x is 4, y is going to be 4. This is the general appearance of your linear function. About the properties, the domain is -infinity to infinity. You see the graph goes forever left and right. The range is the same, -infinity to infinity. The graph goes forever down, forever high. You notice that you have a y-intercept, and it is the same as your x-intercept. That intercept is the origin. Moving right along. What else have we got? The quadratic function. If we graph that quadratic function, when x is 0 and you square it, you've got 0. If x is 1 and you square it, you got 1. When x is 2 and you square that, it makes 4. A mirror image on the other side of the y-axis. -2 squared makes +4. The graph of a quadratic function, in general, is a parabola. About the properties. Well, the domain is still -infinity to infinity, forever left and right, no denominator, no square root. The range, however, has a boundary. Our range is everything from 0 to infinity. Bottoms up, we say. There is a y and an x-intercept. The x-intercept, the same as the y-intercept for both. It is the origin again. What more? The square root function. Oh, look at that. Now we call this the square root function. I'm not going to say radical because we have other types of radicals. If we go to plot this, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. I'm staying away from taking the square roots of negatives because the square root of negatives, that's not real. Your domain begins with 0 and goes to positive infinity, looking left to right. Your range starts as low as 0 and goes to positive infinity, going bottoms up again. As for your intercepts, your x-intercept, your y-intercept, it's the same for both, just the origin. Oh, more for me. The absolute value function. The graph of an absolute value function we know looks like a V. The absolute value of 0, the absolute value of 1, the absolute value of 2, the absolute value of -1 is 1, the absolute value of -2 is 2. When we graph this, we get a V. Absolute value makes all numbers positive, with the exception of 0. Your domain, looking left and right, is -infinity to infinity. Your range, looking bottom to top, we start at 0 and go off into positive infinity. As for intercepts, same story. Our x and y intercepts, they are one and the same, the origin. Let's have more. The cubic function. Now the cubic function looks like a snake. If you cube 0, you've got 0. 1 cubed is 1. 2 cubed makes 8. Looks like I might be able to reach that. -1 times -1 times -1 is -1. And -2 cubed, I got it right down there. Connect these dots. I'll try. When I connect them, I see that snake shape I have come to expect. About the properties. The domain, forever left and right. You have no denominator, no square root. There is no restriction. The range, forever to the bottom and to the top. Your intercepts, oh, they're one and the same again. That would be your origin. What else? Ah, the inverse, the cube root. So for the cube root, we're looking for perfect cubes. The cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8, our next perfect cube, is 2. The cube root of negative 1 is negative 1. And the cube root of negative 8 is negative 2. Connect them, and what have we got? The sideways snake about the domain. This graph goes forever left and right. About the range, forever to the bottom, forever to the top. We see only one intercept. The x and y intercepts, still the origin. What else? One more. This would be our, back to that one. That's our cube root. I forgot to give the name. Next one we have is our rational function. And there is a problem. The bottom can never be 0. And we'll talk about this more in the future. But 0 is off limits. The graph will not go there. If I were to let x be 1 and plug it in, the y would be 1. If I let x be 2, the y is a half. I can keep on, or just make a nice curve and wait to see more about that later. If I plug a negative 1 in for x, y is negative 1. If I plug a negative 2 for x, y is negative a half. And I'll make a curve that approaches boundaries and does not touch. About the properties, more to talk about that later. The domain is everything except thou shalt not divide by 0. We get close to 0, don't touch. Stop, start again, close to 0, no touching. And the range happens to be the same thing. How low does he go? To negative infinity, up to 0, stop, start again. Everything from 0 to infinity. It appears I don't have any x or y intercept. That's what I wanted to tell you about your parent functions.